Hi, and welcome to this clip looking at percentage yield. It's an aromatics-based question, so it's a part of a question on phenols, but it's using the mass to moles method. There is another method where you just stick with masses, and I'll explain in a little moment when we look at the mark scheme at the end. So I'm just going to pop the laser pointer on so that I can point at things as we talk. So this is from a pack of questions on aromatics, and earlier on in the question, it talked about this equation. So this equation applies to this section of the question as well. So I've taken the equation up to the top of the screen so we know what we're talking about. The reason it's important is because there's a 1-to-1 mole ratio between phenol and nitrophenol. It doesn't matter which isomer we're talking about. So nitrophenol in general, 1 mole of nitrophenol comes from 1 mole of phenol. So it says a yield by mass of 27% for 4 nitrophenol. So this is 4 nitrophenol. Calculate the mass of 4-nitrophenol that would be produced from 100 grams of phenol. I'll show you working and give you an answer to an appropriate number of significant figures. So let's take the data in those equation roles answer method. That allows us to collect the information and process it one step at a time. So the mass of C6H508 is 100 grams. That means the moles is that mass divided by molar mass, giving me 1.0638297. I put a dot there because it's quite a long number, so I'm just showing the examiner that I'm putting in my calculator value. So from the equation, it's a 1-to-1 mole ratio, like we talked about already a moment ago. So that means the expected moles of nitrophenol, assuming 100% yield, is 1.0638297, like that. So it's the same number of moles, but it's a 1-to-1 mole ratio. So to do the answer, I've got to think about how we work out percentage yield. Now, normally, you have the actual number of moles and the expected number of moles, and you divide one by the other, multiply by 100, and that gives you the percentage yield. But they have given you the percentage yield this time around. So we'll be a little bit careful. It's a bit more applied. So the 27% equals the actual number of moles, because the actual number of moles will give you the mass of nitrophenol. Remember, we're looking for the mass of nitrophenol that would be produced from 100 grams of phenol. So we know that we have 27% as our yield. We know that the expected number of moles, if we had 100% yield, would be 1.0638297 ... So we need to rearrange that so that we get the actual mass. So the actual mass is the actual moles times the MR of C6H4OH-NO2. I think is 139 grams per mole. And that gives us 39.9 grams. So why do I do it as 39.9? Because the one piece of data we're given is in 3 sig figs. So it's expressed as 3 sig figs. Now, if we look at the mark scheme, it does it a slightly different way. It does it by just using masses. But it doesn't really matter which way around you do it, as long as you get to 39.9. Okay, thanks for listening. Until next time, see you soon.